Hello there. I hope you all are doing great. And today I'm uploading this video to have an announcement. In today's world, it is not difficult to find solutions related to math or any subject because you can easily find it in the internet. But I have recently came to know that most of the students are facing problem related to the circles, and they are not getting the appropriate explanation and appropriate answers in the internet. They are having difficulties to find the solutions for the problems related to the circles. So today I want to announce you that I will have a campaign from today, starting from today, and every day I will upload the video related to the circles by proving the problems related to the circles. So students, from today I will upload the solutions related to the circle to cover all the problems for the secondary levels, and I hope you will keep in touch to get updated. And today I will explain all the theorems related to the circle so that it will be easier for you when I use those theorem to solve the problems in my further video. So that let's start. uh, uh, if this is the circle and this is the center of the circle, and if this is the angle at the center and this is the another angle at the center, then there is one theorem which says that a angle at the center, if the angle at the center are equal, it means that if these angles and these angles, the value of these angles and these angles are equal, then we can say that this arc and this arc is also equal. It means that ABCO, if AOB and BOC angles are equal, then we can say that AB arc and BC arcs are equal. And the converse is also true for it. It means that if the arc is equal, if the arc are equal, then the angle can be said as equal, and if the angles are equal, then the arc are equal. Another theorem is equal arc on the circle subtend equal arc. That means that if this is one chord and this is another chord, and if these two chords are equal, then this arc and this arc are also equal with each other. And the converse is also right. If the arc are equal, then the chord are equal, and if the chord are equal, then arc are equal. This is the converse theorem. And another theorem is related to the angle formed at the center and the angle formed at the circumference of the circle. It means that if it is the center and one angle is formed at this center and another angle is formed at the circumference but sharing the same arc, that is, it means if AB is the arc of the circle and O is the center, and this is point C is the point somewhere in the circumference, then you can see here this is one angle and this is another angle. This angle is formed at the circumference of the circle, but this angle is formed at the center of the circle. And if the uh, angle formed at the center and the angle formed at the circumference are sharing the same arc, this means that both of these angles are sharing the common arc, that is AB. If the angles are common same, then we can say that the center angle is always double to the circumference angle. It means that the center angle is always the double of the circumference angle if they share the common arc. You can also say that this angle is half of this angles, or this angle is double of this angles. This is another theorem. And similar ways we have got another theorems here related to the, if this is the circle and if we draw here one angle at the circumference and another also angle also at the circumference but with the common arc. If this is the AB is the common arc and C and D is another point at the circumference, then you can see here two angles, one is ADB and another is ACB at the circumference, but both of those angles are sharing the common arc, that is AB. That means that if the angles formed at the circumference of circles are sharing the common arc, obtain the common arc, same arc, then these two angles can be said equal, or these two angles are always equal. This is the another theorem for the circle, very important theorem for the circle. And another another theorem is related to circle is, if this is the circle and you can draw here one cyclic quadrilateral Actually, what is cyclic quadrilateral? Cyclic quadrilateral is nothing, it's just a quadrilateral whose all the four vertices touch the circumference at any point of the given circle. A, B, C, D. This is the example of cyclic quadrilateral. And cyclic quadrilateral, the opposite angles. If this is the one angles of the cyclic quadrilateral, this is the opposite angle of this angles, and the opposite for this angles is this angle. So that there is one theorem which says that the sum of the opposite angles of the cyclic quadrilateral are supplementary or 180 degree. It means that angle C and angle A, if we add the angle C and angle A, then the sum is always 180 degree. If you sum of the angle D and angle B, then it will always be 180 degree. This is the another theorem for the cyclic quadrilateral, and I will add here another theorem too. If it is the cyclic quadrilateral, and if you extend this side, you can extend any of the four sides. If you extend these sides, you can see here one exterior angle here, and this exterior angle is always equal to the opposite interior angles, opposite and interior angles of the cyclic quadrilaterals. It means that the exterior angle of cyclic quadrilateral is equal to the opposite interior angle. This is also another theorem related to the cyclic quadrilateral. And another theorem is, if this is the circle and if this is the diameter of the given circle, then you can say that the angle formed at the semicircle is always complementary or 90 degree. That means that if this is the diameter and this is the angle at the circumference, then this angle is always 90 degree. This is always 90 degree. The angle formed at the semicircle is always complementary or 90 degree. This is also one of the most important theorem for the circles. The angle formed at the circumference of the semicircle is always 90 degree. This angle is always 90 degree. One small thing is, if this is the circle and if I draw here two parallel lines, if this line is parallel to this line, or simply the chord, if the two chords are parallels, then you can say that this arc and this arc are also equal. It means that parallel lines always subtend the equal arc in the circle. The converse is also true. If the two arcs are equal, then two lines are always parallel. If the two lines are parallel, the arc are equal, and if the two arc are equal, then the lines are parallel. If the lines are parallel, then the arc can be said as the equal. These are the basic theorem for the circle, and from my next video I will start uploading solutions for the problem related to the circles. See you in next video.